And with that, Belle, we take a look at our Spiral 7 review. Starting with our first page, which is transforming functions. The second of these is going to be the video today. We've got a graph of the solid line guy. That's the one that's down below. And that is being transformed into the dashed line graph, which is up above. So the first thing that I notice in terms of this, I'm going to look at the horizontal stuff first because the vertical part's a little bit more confusing, is that this graph, if I look at the endpoint here, this is that endpoint on the other graph. It looks like it's going 1, 2, 3, 4, 4 left. And if I think about this, if this graph went 4 left, so this got to be 1, 2, 3, 4, we'd have like this. It would look something like this. And as soon as I see this as a graph, one of the things that I notice is that these points appear to just be reflected over the x-axis. So because I looked at the horizontal part first and then kind of sketched that to get some help, I was able to notice that this is just flipped over x-axis. And there's no other multiplier, there's no other vertical slide for that. What that means that we're looking at negative f, and that's going to be my flip. And 4 left means x plus 4 on the inside. At that point, that problem is done. I'm going to erase the stuff that I did on my graph, just so I can use that for the next part. Okay, h of x is equal to f of x minus 1 plus 5. So x minus 1 means that's going right 1, and then plus 5 means that we're going up 5. That's taking my original graph, which is the solid one, and the points are going up 5 and 1 to the right. So this point would now be up high. My second point, 1 to the right and up 5. My third point, 1 to the right and up 5. And my final point would be 1 to the right and then up 5. I like doing these all separately. I even like doing the separate colors just so I can see what's going on there. The other recommendation I have is to connect them as you go so that you end up having the same shape at the end that you do at the beginning. That's a really important thing. Next up, we've got graphing and solving, and here we're going to have this split into 2 pages just so we can have lots of room to deal with this. We got 2 of these as video and 2 of them is not video. The first video graph I'm going to do in red. And the first thing I notice is that I've got a vertex because this is a parabola. X squared means that we're going to have some kind of a parabola shape. The negative out front means this is going to be a down parabola. And looking at the vertex, we're going to be at positive 2, the opposite of the inside, and positive 1. So I'm going to make that point first. Positive 2, positive 1 is here. Negative 3 means that from both sides I'm going to go down 3 and 1 each way. If I can get these things to actually show up. There we go. So that means from my vertex I'm going to go down 3 and 1 to the right, go down 3 and 1 to the left, and make a nice smooth parabola through that so we can see this is a U. Please be careful to make this a parabola and not an absolute value. This is not a V. C, however, which I'm going to do in blue, is a V. This is an absolute value graph. It's negative, so it's going to go down. And I have a vertex of negative 1, comma positive 1. So we're going to go negative 1, positive 1. That's my vertex for C. And the negative in front means that I'm going to go down 1 and 1 in both directions. So that means that those would be my next 2 points. My absolute value would be a nice V with some really clean straight lines. And that's it. Continuing the graphing and solving, we've got to solve an absolute value equation. And I know that I've got to get the absolute value part by itself. So what I might do is add 5 to both sides. I should zoom in more so I have more room to write. I get -2. I'm going to make my box. 3x plus 1 is on the inside. And -11 plus 5 is -6. Can divide both sides by -2. We get the absolute value of 3x plus 11 is going to be +3. We know for absolute value I've got to end up with 2 equations. One is going to be the positive, the normal one. 3x plus 11 is equal to 3. And then I'm going to have a -1, which is -3x plus 11 in parentheses is equal to 3. I might start that one out by dividing both sides by a -1 and ending up with 3x plus 11 is equal to -3. Okay, why don't I finish this problem up? So -11 to both sides. 3x is equal to -14. And then that, when I divide by 3, I get x equals -14 divided by 3. On the left side, I'm going to -11 to both sides, and I get 3x is equal to -8. And that means that x is equal to -8 divided by 3. All right. Here we have Miss Perry throwing empanadas, obviously because she's a Spanish teacher, she has to throw empanadas. And we have the height of an empanada in the air, can be modeled by this equation, and we've got to answer some questions about this. You might notice these are the same questions that were asked in the last review, but with a different context. So how high off the ground was Miss Perry when she threw the empanada? This is a y-intercept question, and graphically we'd use the y-intercept. The equation, we're going to plug in x equals 0. In terms of how that would look, we end up with e of 0, which means the height at time 0, -5. 0 minus 2 is -2 squared plus 125. So we're going to have -2 squared is 4. -5 times 4 is -20. E of 0 would be 105. So 105, I think this is in meters. That's a really high school for that, I guess. But that's okay. When will the empanada be at its highest point? Highest point, I want to think vertex. On the graph, this is going to be whatever this maximum the vertex is. The x would be the time. The y would be height. Based on the equation, the vertex is at 2, 125. So at 2 seconds, it's at 125 meters. When will the empanada hit the ground? Okay, this is an x-intercept question. And we're going to use the graph to show this information. If we're looking at a graph, those are the x-intercepts. Probably that's the only one that matters, because this is probably going to be a negative value. Using the equation, we'd have 0 is equal to -5 t minus 2 squared plus 125. If I minus 125 to both sides and then divide by 5, I get 25 is equal to t minus 2 squared. Sorry, I did those two steps in one just to make some room here. If I take the square root of both sides, the one thing I have to be careful of is that I end up with 5 is equal to t minus 2, which means that t equals 7. This is a different color. Then we get -5 is equal to t minus 2, which means that t equals -3. We mentioned that we'd probably get a negative value. That one doesn't make sense for time. You can't have -3 seconds after the fact. You'd have to have a time machine. So at 7 seconds, it would hit the ground. 16, the questions are all about plugging numbers in. How high will it be when means that we're finding e of 5. And for that, it's going to be negative 5. And that's going to be 5 minus 3 squared plus 125. 5 minus 3 is going to be 2. 2 squared is 4. Negative 20 plus 125 is 105 meters after 5 seconds. And then e of 10, negative 5, 10 minus 3 squared plus 125. When we do that out, we'd end up with negative 5 times 49, which is going to be 250. Oof, that's a big number. Minus 5, so I'm going to say negative 245. There's a pretty good chance that's wrong, but that's okay. I'm trying to do this quickly in my head. And then if I add 125, I get negative 120 meters. This one's weird because it would be below ground. Cool. Ever onward, we got to find the zeros of some equations. The first one I notice is in vertex form. We just did one that's very much like this. So I know I have to set this equal to 0. I got 3 times x minus 5 squared minus 27. Add 27 to both sides, and I get 3 times x minus 5 squared, which means that 9 is equal to x minus 5 squared. I want to take the square root of both sides. I'm going to end up with 3 is equal to x minus 5, and negative 3 is equal to x minus 5. I need both versions of this. If I add 5 to both sides, I get 8 is equal to x, and I get 2 is equal to x. Those are my two answers. Number 18, number 19, this one's set up nicely for us already. 0 is equal to 2, then we got x minus 6, x plus 7. That means that I need to take the things in parentheses. In this case, x minus 6 equals 0, and x plus 7 is equal 0. That's based on the idea that if two things are multiplied and the answer is 0, one of them has to be 0. So x equals 6 and x equals negative 7. For number 20, I'm going to try factoring. I'm looking for things that multiply. A times c is 24, and b is negative 10. Things that multiply to 24 and add up to negative 10. I know they've got to be negative because I'm adding up to a negative. So I'll start with negative 1 times negative 24, which is negative 25. Doesn't make sense. Negative 2 times negative 12. Ooh, that's promising, but that's negative 14. Okay. Negative 3 times negative 8. That gets me negative 11, even closer. Negative 4 times negative 6, and we have our winner. That means I'm going to rewrite this as 0 is equal to 3x squared minus 4x minus 6x plus 8. I group the first two. They only have an x in common. So I'm going to write that as x, and then I get 3x and a minus 4. The next two, these guys have a 2 in common. I'm going to get minus 2 to get rid of that negative. And I'll put 3x and minus 4 when I divide. And finally, I forgot my equal 0. We get 0 is equal to the two things that are the same, go into one parentheses, 3x minus 4. And the x and minus 2 make their own. That means that 3x minus 4 is equal to 0, which means that x equals 4/3 when you finish that up. And we get x minus 2 is equal to 0, which means that x is equal to 2. Okay, for 22, we've got to do a bunch of stuff for this. So I'm going to start by writing in factored form. And I'm looking for things that multiply. 1 times 24 is 24, and add up to negative 10. Based on the last problem we just did, which had the same things, that's going to be negative 6 and negative 4. So we've got x squared minus 6x minus 4x plus 24. We've got an x in common, we got x minus 6. We get a minus 4 in common, so we get x, and then 24 divided by negative 4 is minus 6. That gives me x minus 6, that's the thing in both parentheses, with leftovers of x minus 4. That's factored form. B, find the zeros. This is basically continuing the same problem. So we got zeros equal to the factored form, x minus 6 and x minus 4. That means that x equals 6 and x equals 4. C, find the vertex. If you'd like, you can find the vertex exactly between those, or you might use a tool from the next page, which is the quadratic formula stuff, and know that x is equal to negative b over 2a. We talked about that as always the vertex, which in this problem is going to be negative 10 divided by 2 times 1, which is 10 over 2, which is 5. Then I've got to plug that in. Doesn't matter what I plug it into. I tend to like plugging it into my factored form. So we've got y is equal to 5 minus 6 times 5 minus 4. And when you do 5 minus 6, you get negative 1. 5 minus 4 is 1. We get 5 comma negative 1 is my vertex. Dealing with that, then we got to find the y-intercept. So that was part C. Part D, you might recall that if you plug in 0, you just get that last value. That's totally fine. Or you might plug it in here and get negative 6 times negative 4 is positive 24. The graph of this, we've got a y-intercept at 24. We've got a vertex at 5, negative 1. We've got zeros at 6 and at 4. And we've got a nice sketch that looks like this. Ever onward to our last section. The new stuff, quadratic formula and complex numbers, which is going to be feedback only this time. First thing that we want to do is to predict how many real zeros we expect to find. The big idea here is that if b squared minus 4ac is positive, in other words, the square root comes out to some kind of a whole number or a decimal, we should have 2. If it's 0, that means that this whole piece goes away and you're left with just the vertex. You end up with a 1, 0. And if it's negative, that means that inside the square root is negative, means we have an imaginary number, and that means that we have no real zeros. I like how I changed colors before I wrote that. Okay, first one, we've got 24, so 2x squared minus 9x plus 1. Quickly, 8 times c is 2. Nothing 2 can ever add up to negative 9, so this is not factorable. Expectation is probably that most of these are not factorable. So I've got a equals 2, b equals negative 9, c equals 1, b squared minus 4ac, just to kind of check at the beginning. We can also use this in a minute. Negative 9 squared, please use parentheses, minus 4 times 2 times 1. 81 minus 8 is going to be 73. It's positive, so we're expecting 2 zeros. That's what I mean by use the discriminant to decide what to expect. Now plugging this in. Negative 9 over 2 times 2, plus or minus the square root. And hey, we did b squared minus 4ac already, so I can just type in 73 there. By typing, I mean write. And on the bottom, we got 2 times 2. Your final answer would be positive 9 over 4, plus or minus the square root of 73 over 4, or something that's equivalent to that. There's nothing to reduce there. No video. I'm going to try my factoring thing first. 3 times 2 is 6. Oh, I can do that one as factoring. This one is factorable. I highly recommend that you factor it, but because this is a quadratic formula section, I want to make sure that we're okay with this. I'm also going to do that b squared minus 4ac thing. Don't have a lot of room, so I'm just going to kind of deal with this here. We get negative 5 squared minus 4 times 3 times 2. 4 times 3 times 2 is going to be 24. That's going to be 1. That means we should have 2 zeros. Plugging this in, negative 5 over 2 times 3 is 6. Plus or minus the square root, and we said b squared minus 4ac was 1. And that's going to be over 6. So that's going to be positive 5/6 plus or minus square root of 1 is 1/6. 5/6 plus 1/6 would be 1. And 5/6 minus 5/6 would be, 5/6 minus 1/6 would be 4/6, which is 2/3. For number 27, 2 times 11 is 22. Nothing from 22 is going to add up to negative 10. This is another quadratic formula one. Again, I'm going to start off with my b squared minus 4ac just to check what to expect. That's going to be negative 10 squared minus 4 times 2 times 11. And when we do that, we end up with 100 minus, that's going to be 88, which is 12. Okay, plugging things in, there's my A, B, and C. Remember that the negative goes with the 10. So negative 10 over 2 times 2 plus or minus the square root. We already found that as 12, and that's going to be over 2 times 2. So 10 over 4 plus or minus the square root of 12 over 4. This is reducible, but I don't need you to reduce it for this problem. Next up, we've got some things involving some complex numbers. I've got the square root of negative 20. We've got to write that as negative 1 times 20. And if you really want to go further, but you don't have to, you could write 20 as 4 times 5. And when you do that, the square root of 4 is 2. So you can write this as 2i square roots of 5. But it's also okay to go here and write this as I square roots of 20. I'd be okay with that. For number 31, adding means we're combining like terms. 3 plus 6 is 9. 5i minus 2i is going to be 3i. And at that point, we are done. For number 32, we got to do some distribution. We got 20i, and then 4 times negative 2 is negative 8, and I squared. We need to know that I squared is the same as negative 1. So that really means this is negative 8 times negative 1, or plus 8. I'm going to rewrite this in opposite order, so we get 8 plus 20i. And finally, for number 34, we're going to have 2i times 2i, which is going to be 4i squared. 2i times minus 3 is minus 6i. Plus 3 times 2i is plus 6i. And then plus 3 times minus 3 is minus 9. 4i squared is negative 1, so that's really negative 4. Negative 6 plus 6, hey, that cancels out. I'm just going to write plus 0 and then minus 9. In an interesting turn of events, we get no i's in this problem and just negative 13. That happens sometimes, and that's due to these being the same term, but with a plus and a minus between them, which is kind of a special thing that we'll talk about more later.